Coulomb's law. If two objects have electrical charge Q1 and Q2 and they are separate by distance r, then the Coulomb's law says that electrical or Coulombic force between the object K Q1 Q2 over r squared. K is a Coulomb's constant approximately equal to 9 10 to the power of 9 nanometer square over Coulomb square. As we know, matter can be electrical charge. Charge can be positive, negative or neutral. If an object is neutral, it has zero electrical charge. Coulomb's law said identical charge that is charged with the same sign will repel each other, while opposite charge will attract. Besides, the neutral charge won't attract with electrically charged object. Also, the closer two charges are, the stronger the force between them. Coulomb's law also relates the force between two objects to their electrical charge. Lastly, Coulomb's law is an inverse square law, so distance are very important.
In this experiment, the main objective is the factor that affect the force of electric charge. During the experiment, there are two types that factor that affect force of electric charge, which are the quantity of charge and the radius between two charges. The hypothesis of the experiment is the force of electric charge will increase when the quantity of charge is increased. Then, for the radius, the force of electric charge will increase when the radius between two charges is decreased. For the data collection, we use the online simulator from the PhET simulator. From the experiment, the manipulation variable are the quantity of charge and the radius between two charges, while for the observation variable is the force of electric charge.
For this experiment, we use online simulator, which is PhET simulator. Using this simulator, we want to collect data on how quantity of charge and the radius between two charges affects force of electric charge. Please take macro scale. In the macro scale, we can move the guide and you can notice the value of force changes. It shows how strong this charge attracted to each other. This value is the value of quantity of charge. Firstly, we want to collect data on how quantity of charge affect force of electric charge. To collect data, we must remember that in the experiment, there is only one variable can be changed. Therefore, we want to change quantity of charge Q2, meanwhile Q1 and radius we set constant. Radius we set on 2 cm, while the Q1 we set on -3 microcoulomb. So we want to collect data from 4 microcoulomb. The produced force attracted is 269.6. If we want to increase the quantity of charge Q2, the force produced will be increased, which is 337.0. Same goes to the 6, 7 and 8 microcoulomb. Right now, we want to collect data on how radius between two charges affect force of electric charge. This time, we want to change the radius between two charges, while the quantity of two charges Q1 and Q2 remain constant. Q1 we set at -3 microcoulomb, while Q2 we set at 4 microcoulomb. So we can observe the force produced at 2 cm is 269.6. If we move further at 4 cm, the force produced is 67.4 Newton. This shows as the radius increases, the force produced is decreases. And this is the data collection that we done from the simulation.
After we collect all the data from the simulation, we're going to analyze the data by plotting the graph from the table. From the plotted graph, we can determine the relationship of the experiment. After plotting the graph for table 1, we can observe the effect of charge on the electrostatic force. From the graph, the quantity of charge is directly proportional to the force. From table 2, the plotted graph was to determine the effect of radius between charges on the electrostatic force. So this is the graph of force versus the radius between the two charges. From the graph, we can see that the radius between the two charges is inversely proportional to the force. From the two graphs, we can see that the force is directly proportional to Q2 and the force also is inversely proportional to 1 over r squared. This is correspond to the Coulomb's law, which is F is equal to Coulomb's constant times with mod of charge Q1 times mod of charge Q2 divided by R squared. Therefore, the experiment is a success.
In conclusion, the main findings from this experiment are able to understand the concept of Coulomb's law and also study the effect of quantity of charges and the distance between two charges toward the electric force. To conclude the experiment, we know that the electric force will increases as objects move closer together. It is because the electric force is inversely proportional with the square of the distance between two charges. In the other hand, the electric force will increases as an object charge increases because they are directly proportional to each other. I think that's all. Thank you.